So, in this module, we are going to learn about database design and normalization. From the Canvas description of the module, you will find all the summaries and also the learning objectives. I'm not going into that detail. So, let's go through the normalization. In the part one, we are going to discuss about the basic aspects of the normalization. And also, we want to talk about what's the problem we are talking about. Why do we need normalization? Basically the context of our issues. So, when we do talk about the normalization, so to define the normalization process in respect of database design, you can talk about a series of uh, steps you can adopt to identify and correct the redundancy in the data and also some other problems such as integrity that occur when data is stored in one large table. The basic process breaks column into smaller tables to identify entities and facts about each entity. The normalizing minimizes redundant data that improves the data consistency, reliability, and accuracy. Now, to describe the problem, let's a little bit bring up an example. Basically, a case study. In this example, we have a sample list of data about students and their faculty advisors, and we can demonstrate the steps in normalization process using this master database. Master data table. So the list starts with some unique student ID in the first column. The column number two is the student's full name. The third column is a unique value for each teacher, an attribute named Prof ID, and then you have the first name, last name. So you can have the first name, last name, department, and then you have the measures for the student. So it is driven by the student. It is starting with the student ID, then you have the student name, then you have information about the teacher here, then you have the department specific information, and then again it's a student specific, like what are the measures the student is having, each student is having. So this is the database we are starting with. So, okay, so this is a good way to organize your data, but it includes, you can see many things like students, professors, departments, and majors, and faculty student advisory assignments as well. So you can see here, this kind of information you can see. Now, there are there are three problems mainly. You can see too many information in a table. So, you know what is the problem with too many information? The main problem is it's very hard to maintain. Then it contains duplicated data. You can see here that department has a lot of duplicate data. The major, not major, the professor, this field where you have the professor information, that also has duplicated data. So basically you have a lot of duplication. So I mean that's the problem, right? When how do you update? If you need to change the data, then you have to change multiple places, and there is no single query to find out all the possible changes for a given field. And you can also see that there are multiple fields that has similar category of data, like the measures, measure 1, measure 2, measure 3. It's another problem. If a student wants to have another option, measure 4, then you have to add columns horizontally to it, which is not a good practice anyway for the database from the maintenance perspective. So all these things, if you combine together, the problem is you may you can have a potential to end up with losing accuracy, and also the query on this table can be very harder, can be very challenging, and there is no guarantee that the queries will give you the correct results. So that is the problem with this table. So once we identify the problem, so we can see how we can divide this problem into different categories. I mean, in order to solve the problem, it is basically the problem is related to data modification as well as data query. So if you think about the data modification issues here, you can see that there are three categories of problem you can have from this table. So first of all, I mean, whenever we talk about data modification anomalies, we divide it into three different types. I mean, data modification has three types. Insert, either you insert or you update or you delete. These are the three scopes within data modifications, right? So three types of anomaly, and let's see on the table itself what are the different anomalies. For example, you can see that in here this data does not have any student ID at all. So I mean, if you want to insert something to this, I mean, you cannot insert it because it is I mean, you cannot add the data because uh, the other data is absent, that is the primary key is absent. So if your student does not have the student ID, the new student may not be assigned to a professor at all. There can be a problem with that. And then if you think about the updated anomaly, I mean, this is marked by data inconsistencies that generally results from data redundancy here. So if you want to update, for example, this field, this particular values technology to something else, let us say um, like industrial technology or computer technology, whatever it is, then you cannot just update one field. I mean, on this record only, because you have to update all the records that matches technology. So that may require deeper queries, deeper update efforts than you think about. And if you have a table with, let us say, 5,000 students, it will be very hard to find those records. I mean, when you are going to update all those things. So this is complex. So, and then the delete anomaly, I mean, is the unintended loss of data due to deletion of other data. For example, if this particular student, so Sandra Mines, they drop, then, or maybe the professor Steve Kim, the professor retires and a record with his name is deleted, the information about what student they advised will be gone, right? So basically, these are the main problems with this type of table design. So how do you solve these anomalies? I mean, the way you can solve it is by normalization. So how the normalization helps to solve this problem? The normalization basically takes a single list and converts it into multiple tables that frees the data from the problems associated with insert, update, and delete anomalies. So that's our problem region, I mean problem domain. So in the next video, we are going to discuss about uh, more uh, in, more insight into how do we approach the normalization. So when we talk about normalization, basically we are thinking about there are in general there are four types of normalization: first, second, third, and fourth normal forms. We are going to discuss about what are those uh, forms in particular. So first normal form is usually written as 1NF. The second normal is written as 2NF, as I am writing here. The third normal is written as 3NF, and the fourth one is written as 4NF. So in the next slides, we are going to discuss about how do you approach the normalization problem and what are the solutions. So in this short video, we learned about our problem. I mean, when you have a table with a lot of information in that, then there is always potential to have three anomalies: insert, update, and delete. And we have shown you, we have discussed the domains of these three anomalies. Okay, if you have any questions, don't hesitate to comment on the video or email me directly. Okay, thank you. Talk to you soon.